ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. Greetings of the day, dear students. Today we are here to discuss about experiment number 10. The name is Serial Communication of 8051 Development Board, which comes in the course PCB Design and Fabrication Lab under the program Electronics and Communication Engineering for Semester 5 Diploma students. A warm welcome to all of you to the session. So let us see what is this serial communication of 8051 development board. Okay, for 8051 what is serial communication? I will show you the circuit diagram. Okay, this is the circuit diagram for serial communication. Okay, it requires a max 232 IC, 16 pin IC. Then I require a DB9 connector, 9 pin connector it is. Then I require 2 pins which comes from 8051 microcontroller. So I require a 2 pin connector for this purpose. One is coming from pin number 11 of 8051 microcontroller and other will come from pin number 10 of 8051 microcontroller. For this I have to take a 2 pin connector. Then if you see the circuit diagram, I require 4 capacitors named as C1, C2, C3, C4, and then I require VCC, ground, and for each VCC and ground I require associated power flags. Okay, this is the circuit diagram. Now what is this serial communication? Little bit we should know, that is 8051 pin number 10 and 11 are used for serial data communication, that is sending the data serially from microcontroller to external device or external device to microcontroller. For that, microcontroller always uses TTL level, that is 0 volt and 5 volt level. Whereas whenever you interface with this with the external device or any computer, it requires RS232 voltage levels. Okay, so therefore I require RS232 level to be converted into TTL or TTL to be converted into RS232. Okay, so for that I use a IC called MAX232. So MAX232 converts TTL to RS232 or RS232 to TTL voltage levels. So that I can use efficiently the serial data communication. Okay, so this is the brief thing regarding serial data communication and the requirement of MAX232, and DB9 is required to connect from microcontroller MAX232 to your computer or any other external device. This DB9 9 pin connector is required. So now let us begin the experiment, that is designing of PCB layout for this experiment. So once again quickly we see what are the requirements. One MAX232 IC, one DB9 connector, one 2 pin connector for connecting from microcontroller, and one more 2 pin connector for connecting VCC and ground, and then components required are VCC, ground, and associated power flag, and 4 capacitors. These are the components I require. Okay, so now let us see the experiment. As all of you know, what we require is, so in the previous 9 experiments we have seen, first I have to click on this keycad, double click on this, then a blank keycad screen will appear. In that file new, okay, and in that file new, okay, I will show you. So whenever this in this you show file, and then in that you have to click on new, then in there you have to click on blank project. Okay, so then it will ask for a name, so you have to give the name. Already I have given the name experiment 10, it will saved as experiment.pro. Okay, this is the first step. Then you are opening the schematic editor. Okay, so you open this schematic editor. Okay, so you have to open this. This is the schematic editor, because I have collected the components. I will show you how to collect the components. Okay, first I require MAX232. MAX232 is present. You have to go here, place a component, then click anywhere, then list all, then go for special, because it is present in a name, under the name special. Here there is a special, click here. In that you search for MAX232, or you can type there for quick search. Okay, here it is there, MAX232 IC. You can say take this. Okay, okay, this is the MAX232 IC. In this way I have to collect it, because already I have collected. Okay, so I have shown you how to collect that MAX232. This is new IC for you, which is not covered in previous 9 experiments. Then I have collected DB9 connector also. Okay, this DB9 connector, again you have to go here, place component, Okay, then say list all, then go for CONN, that is, this is a connector, so you go under the name CONN. Okay, here it is CONN. Okay, go here, and here you can type it or search it, db9. I will type db9. See here, db9 will come. Click on this and select this. Okay, in this way db9 connector will also come. You keep in the on the screen. Okay, I have collected, therefore I will remove it. Okay, then already you know how to collect these 4 capacitors. That is, go here and say list all, and capacitors are present in device. Okay, go to device. So here it is there, device, then say here, and in this you search for CP, it is there CP. Okay, in this way you can collect 4 capacitors, and then 2-pin connectors. I require 2-pin connectors. Okay, and already you know how to collect this 2-pin connector, that is this, then list all, then CONN, it is there present in CONN. Okay, in this CONN you search for CONN2, that is connector 2, it is there here. Okay, you can take this. Okay, after this edit its value. For example, right click it, edit component. Okay, edit value and reference, both you edit. I have edited, give the name, I have given the name as power supply, and value is ground and VCC I have given. Okay, and similarly you connect one more connector, 2-pin connector, for giving it to from 8051 pin number 10 and 11, that is TX and RX. So collect this, edit its name. I have given the name as TX and RX. These 2 pins are connected to 8051 pin number 10 and 11 of the 8051 microcontroller. So in this way I have collected all the components, that is VCC and ground. You know, it is, they are present in this power flag, place a power port. In this you click here, then say list all, VCC is also present, ground is also present, power flag is also present. Collect all those, and then okay, arrange these according to the circuit diagram. See the circuit diagram which should be with you. Then after that place a wire. I have taken this, then I have by seeing the circuit diagram I have connected all the things, that is click once, then drag it here and double click, one connection is over. In this way you complete the connection. I have completed the connection. After completing the connection, next step is to save. You have to save it. Then next step is annotation. Click on this, then click on annotation, then say close. After annotation, the part names to the different components will be given. Then test for electrical rule check. You click here and test here. Okay, if no errors are there, so here 0 errors are there, then okay. Otherwise, if any pin is not connected, if error is shown, you can ignore it. Okay, except if any missing wires are there, then only you consider. Otherwise, you can ignore the errors. Okay, because here I will show you so many pins are not connected. Okay, in this also so many pins are not connected. Sometimes it will show errors as pin is not connected. You can ignore that. Okay, so in this way this is completed, electrical rule check. Then go for the next step, that is net. In this you click on net list and then say close. Okay, so I have generated the net list. Then go to the run PCB associate components. Okay, so here association of components already I have shown you in the previous experiment. For polarizer capacitor, better you take CP4, 4 polarizer capacitors, and for 2-pin connectors you have to take SiL2 and another 2-pin connector SiL2 I have taken. And for DB9 connector I have chosen the connection as DB9FC, this I have taken. And for Max 232 IC I have associated with DIP16 underscore 300. That is, it is a dual inline package 16-pin IC. That's why I have chosen this. In this way, associate all the components, then say save. Okay, then say quit. Okay, so you come out of this. And next step is, last step for PCB design is run PCB new. Okay, you click this. Okay, after clicking this, okay, so because I have opened it, it will come automatically. So, and here I have shown you. After that, what you have to do is, first step is net, read current net list, net, and then say read current net list, and then close, and then Okay, then what you have to do is, next is click on this, then right click here, globe, move and place, move all the components. If you do this step, all the components will come here. Okay, then arrange them correctly. I have arranged all the components correctly. So then last step is, I have increased the width of this a little bit more. Okay, I have taken it as, for example, 0.4, so that tracks will be looking better. So then select the track. Okay, then go on placing the tracks. Okay, I will start placing the tracks here. Click here. Okay, place the track, double click, then click here and see where it is. It should be connected here, and then click here. Sorry, you click here, you see where it is connected. It is coming here, come here. And now you connect to this point, leave it. Then next you see this, where it is connected. It is connected here. I can go like this. So you can come like this, complete this, then connect next. Okay, just enlarge it and connect it. It will become easy. Okay, it will be connected here. For example, I am connecting here, double click it, then this also you connect it. This is over. Then see where it is connected. It is connected here. So correctly connected. From here you should connect it. I will connect here. Then from here you connect. You see where it is. You connect it here to this pin. Next you see, next how many connections are remaining still. Okay, you can connect from this. You see here it is connected here. You can go like this. It is connected here. Then from here you connect. It is connected, and see from here I am connecting to this pin. This is connection. Next see where the connection is there. You see here one more connection is there. It should be connected here, for example. This is connection. Next enlarge it so that you can see where you see here there is, here to here there is a connection. I will come like this. I have connected, and see one more is there. From here see where it is connected. It should be connected here. For example, I will move like this and connect it here. And last two more connections are there. From here you see where it is connected. It should be connected here. Once again I will connect from here. Go slowly. This is over, and one more connection was left. That is from this. It should be connected to this. Okay, so I will move like this. I will enlarge it. Okay, so that it will be clear for me how to move. move here. You see now. So no white wires I am seeing here. You can see here. Okay. So all the connections are over. Okay. So next step is, as all of you know, almost layout is ready. Only thing is optional step, that is boundary marking. For boundary marking, I will select F silk or F mask. For example, I have selected F mask and click on this add graphics or polygon. Okay. Then put the boundary. Okay. Whenever you want to take a turn, you write once you click it. Okay. Again, I want to take a turn, I am clicking once. Okay, I want to take a turn, I am clicking once, and click once and double click it. Okay, so boundary marking is over. And another optional step is there. I want to give some name to the this PCB. Okay, this is my PCB layout I have designed. You can see here. Okay, this is match 232. This is DB9 connector. All the 4 capacitors are there. Here C3, C1, C2. You can see all the tracks I have placed properly. Okay, you can see here. Okay, so last step is to give the name. Give the name. For example, again you go to the back of the copper and select text, and you can give the name as COMM. For example, COMM for 8051. You can give any name you want. I have selected that name. Okay, so this is the name I have given. Place it at the wherever you want, you can place it. I have placed at the center. Okay, so in this way, so this completes the PCB design process of this experiment. Okay, so I hope I am clear to everybody for explaining this PCB design part of the this experiment. After this, what you have to do is, you go here for fabrication process. You have to go here, file, then say print. Okay, then you can say print preview. Okay, so if you see print preview, your PCB layout will look like this. Okay, it is exactly to the scale. Once again I will show you. Okay, you just see accurate scale 1. You have to, this should be present while taking the printout, because it is 1:1 scale. Okay, so then after that you can observe the preview. It will look like this. Okay, this is the preview. You have to take the printout of this for further fabrication process. Okay, so in this way you have to complete the next step, that is fabrication process. Okay, this is the design part which I have designed for 8051 development board. Okay, so thank you for giving me an opportunity to share my views with you regarding this 8051 development board serial communication part. Okay, thank you one and all. Thank you.